Hold up. Wait a minute. Something ain't right.
Alrighty, let's take a look at rearranging an equation. Now, in maths, rearranging an equation is called transposing. This comes from trans, meaning across, and the original Latin ponere, meaning to put. So we're putting something across. What we're going to do is move things across the equals sign. Now we can do this so long as we remember that when something goes across the equal sign, we have to do the inverse of it. Let's see what we mean by that. Well, let's say something was added. The inverse is essentially the opposite. So what's the inverse of addition? That would be subtraction. Likewise, the inverse of division would be multiplication. So generally things have an inverse. It's a way to undo what was done. If we say had something cubed, let's say we had a cubed, well, what would be the opposite of a cubed? That would be to take the cube root of it. Let's say we had the tangent of something. The opposite of tan would be the inverse tan. So we're going to use the inverse operations in order to transpose, to rearrange an equation to solve for a term that we want to solve for. Our first nice simple example here, s plus 1 equals 3. Now, you can quite possibly do this in your head and come out that, well, s has to be 2 because 2 plus 1 equals 3. However, we're going to go through the method because the same method can then be applied for harder problems. So in this case, what we're going to do is say to ourselves, well, we want the s by itself. We want s equals something. What we don't want is s plus 1. So we're going to grab that plus 1 and we're going to take it across the equals. We're going to transpose it, okay, put it across the other side. But of course, we have to do the inverse. Inverse of plus 1 would be minus 1. So when it's on the other side, we're now left with s by itself, and we have 3 minus 1. And that is, of course, how we get our answer of 2. 3 minus 1 is 2, so s is equal to 2. Let's look at a few more examples. Here we have t minus 19 equals 2. Well, let's grab that minus 19. We'll throw it across the other side of the equals, and that becomes plus 19. So in this case, t is equal to 21. Okay, so we didn't just grab the 19, we grabbed the minus 19. Remember, the sign in front of a number goes with that number. So we took the minus 19 across the equals and it became a plus 19. Now, that's grand for addition and subtraction, but as we'll see, it works exactly the same for multiplication and division. And as I alluded to when we were looking at the inverse operations, it works the same for anything so long as you just do the opposite, the inverse of it. In this case, we want y, great, but y has been multiplied by 8. So let's grab that 8, throw it across the other side of the equals. It was times 8. When it's on the other side of the equals, it's going to be divided by 8, because that's the inverse of times 8. So now we have 48 divided by 8, and that is of course equal to 6. So y equals 6. Likewise for division, r has been divided by 3. Take that 3 across the other side of the equals, and it's going to become times 3. So r is equal to 7 multiplied by 3. 3 sevens are 21. So r equals 21. Now, so far these have all been fairly straightforward examples, just one-step examples. Let's go to a two-step example. In this case, we're trying to solve for c, but we work our way back in towards it. So in this case, we're going to start with that plus 1. We're not going to start with a 9. We're going to start from further out. So that plus 1 across the equals, that will leave us with 9c equals 10 minus 1. So 9c equals 9. Right, now we can get rid of that 9 that's been multiplied by the c. Now we'll grab that 9 and take it across. It was multiplied, so it's going to be divided by. So c equals 9 divided by 9 equals 1. So this example was a two-step method, as is this one. Let's see what we have to do. Let's grab that minus 4 first, throw it across the equals. That will become a plus 4. So 3a, which we're left with, is equal to 8 plus 4, which is 12. So 3a equals 12. A, let's get rid of that times 3. Remember, 3a is 3 multiplied by a. So let's get rid of that times 3. Throw the 3 on the other side. It will become divided by 3. So a equals 12 divided by 3, which equals 4. A equals 4. Another two-step example here. We want to solve for m. Let's get rid of that plus 9. So we still have m divided by 5 on one side of the equals, but when that plus 9 goes to the other side, it becomes a minus 9. So m over 5 equals 11 minus 9, which is 2. Now we can get rid of that divided by 5. Throw that 5 across the other side of the equals. It will become a times 5. So m equals 2 times 5, and that is, of course, equal to 10. So m equals 10. Another quick example here. In this case, we've thrown in brackets, but they won't phase us. We want to get rid of the divided by 4. Now, previously, we were getting rid of the add-on bits, like that plus 9 was the add-on bit, so we got rid of that first. But in this case, we have brackets, so the n minus 31 is actually grouped together. That minus 31 is not just an add-on bit, it's grouped. So we need to get rid of that divided by 4. Let's throw it to the other side. That will leave us with n minus 31. That is equal to 2, and of course it becomes times 4. Wait, that's not a 4. There we go, it becomes 2 times 4. When you take that 4 across, the divided becomes times. We don't need the brackets now because n minus 31 doesn't need to be grouped anymore. But now we can get rid of that minus 31. Actually, we should probably say that 2 4s are 8. There we go. N minus 31 equals 8. Now we will grab that minus 31, take it across, and we have n equals 8 plus 31. So now we can see that n is equal to 39. Let's take a look at a right-angled triangle now with Pythagoras. With the Pythagoras theorem, if we have any two sides, we can of course find the other side. So we have C is always the longest side, the hypotenuse. The other two sides are randomly A and B. It really doesn't matter which is which, they're just the other two. But let's say we actually had some lengths. What should we call this? 4 and 5, and we want to solve for A. How long is side A? Well, now we need to rearrange this equation. So first we'll have A squared is equal to C squared. Now that plus B squared across the other side of the equals is going to be minus B squared. So far so good, but that doesn't give us A. That gives us A squared. Well, let's get rid of this squared. Let's take that across the equals. What's the opposite of squared? That would be square root. So when we have just A by itself, we take that squared across the equals, we now have the square root of C squared minus B squared. Then of course we can throw in our numbers, and that is equal to the square root of 5 squared minus 4 squared. Well, 5 squared is 25, and 4 squared is 16. And 25 minus 16 is 9, so we have the square root of 9, which means that A is equal to 3. Square root of 9 is 3, so A is 3. Another place where we might want to rearrange equations is using trigonometry. Again, with a right-angled triangle. In this case, we have this angle right here, let's call it theta. And once we have the angle, then we can label the other two sides, because the hypotenuse is always this one, grand. But when the angle is labeled, now we have the adjacent side and the opposite side, right? Opposite being on the other side of the triangle from whichever angle you're talking about. So let's say we want to find, I don't know, A. Let's say we have H and we want to find A. So this one, tick, we have our angle, and this one is the question mark. Right, well, we have the hypotenuse and we have the adjacent. Which one uses the hypotenuse and the adjacent? That would be this one. So we're going to be using cos, our cosine, and cos of the angle is equal to adjacent over hypotenuse. So now we just rearrange. We don't want a divided by h. That h comes across the equals, and we're left with a is equal to h times cos of the angle. Now, I'm not going to throw numbers at this one and work it out because, of course, the cos of an angle could well give us lots of decimal places, so let's not go there. But there we have the equation transposed or rearranged. But what if, let's just say, we were given a and we didn't have h? We were asked, what is the hypotenuse? Well, we would still start with our same equation. Car says that cos of the angle is equal to the adjacent over the hypotenuse. But now we want to find the hypotenuse. If we grabbed the a and took it across the other side, we would have h by itself, which is grand. The thing that we're wanting to find, we want it by itself on one side of the equals. But let's do that. Let's take that a across. Well, it was on the top line. When we take that a across, it's going to be on the bottom line, but h is still itself on the bottom line. We don't want 1 over h, we want h. Now, fine, we could do that and then just take the reciprocal of the answer, but it's much easier to, in this case, cross multiply. The subject that you want to find, we want to have it on the top line of any fraction. So let's take that h across the equals. That will leave us with h times cos theta is equal to a. And now we can take that cos theta across the equals, and because it has been times by the h, it will come across and be divided by. So we have h is equal to a over cos theta. But actually, let's have a look at one more option. And the other option is, what if we had two sides? Well, if we were looking for the third side, we would use Pythagoras. But maybe we don't want the other side. Oh no, I just got rid of my triangle. Hold up, let's redraw. Right, so maybe this time we don't want the other side. We have the hypotenuse, tick. We have the adjacent, tick. And we actually don't know what the angle is. Well, in this case, we're dealing with an angle, the adjacent to that angle, and the hypotenuse. So we're still using the same equation, cos theta equals a over h. But this time we just want theta. We want the angle by itself. So now it's the cos that we have to get rid of. That's okay. Cos has an inverse, just like everything else has an inverse. So we grab that cos and we take it to the other side. Now, this is not being multiplied by the angle, so we can't just take it across and divide it. The inverse, the opposite of cos, is, funnily enough, called the inverse cos of a over h. So there we go. We have rearranged the equation. Instead of cos theta equals a over h, we have the inverse cos of a over h to leave us with the angle theta. All right, two more examples. Let's look at a couple that are not simple 1 or 2 step examples. So this is going to involve a few more steps, multiple step example now. Let's solve for v. Right, well, we have 9 equals v plus 4 all over v plus 12. Let's get rid of that division there. We don't want divided by v plus 12. So what we're going to do is take that whole v plus 12 across the other side of the equals. And what will it become? You guessed it. It will become times v plus 12, right? We're not taking just the v, we're not taking just the plus 12. They have been grouped, they're in brackets. So it's a grouping that we're taking across. So we now have 9 times v plus 12, because when the v plus 12 was on the right-hand side of the equation, it was divided by. Now that it's on the left, it's become multiplied by. And of course, we still have our v plus 4 on the other side. Now that that v plus 4 isn't being divided by anything, we don't need the grouping symbols, we don't need the brackets there. Right, so on the left-hand side, let's get rid of our brackets. We've got 9 into v plus 12. Let's expand that out, and we have 9v, because it's 9 times the v. Remember, this thing is multiplied by this, but it's also multiplied by this. So we have 9v, let's just move it down a little bit lower, 9v plus, well, 12 nines are 108 equals v plus 4. Great, except that we've got v's on both sides of the equation. Well, we don't want that. We want one side of the equation with the subject that we're looking for. Everything else on the other side. So this v here, it's a plus v. The positive sign isn't shown, of course, but plus 3 is the same as 3, isn't it? If there's no sign shown, then it's a positive value. So that v, when it comes to the other side, is going to be a minus v. Let's at the same time take this plus 108. So the v came this way. That plus 108 can go that way. That's going to become a minus 108. So 4 minus 108. What we have now is 9v. Take away a v. That's going to leave us with 8v. 4. Take away 108. That's going to leave us with minus 104. All right, we're nearly there. We've reduced that long equation that we had at the start to 8v equals minus 104. And now it's one more simple step. That v has been multiplied by 8. So that 8 we will grab, throw to the other side of the equals. And that will leave us with, I'll just go up to the right now, a bit more room. That will leave us with v is equal to minus 104 divided by 8. It was times 8, now it's divided by 8. And that means that v is equal to minus 13. So there we go. It's a few more steps than we had earlier, but we have still managed to solve for v. Let's do one more fun example like that, because that was quite fun. Alrighty, another multiple step example. Let's expand out the brackets. Let's get rid of those first up. So we have, remember, 3 is times by the x. It's also 3 times by the minus 4. 2 is times by the minus 2x. Also, that 2 is multiplied by the plus 1. So we have 3x minus 12 is equal to negative 4x plus 2. There we go. We've expanded out the brackets. Now we want all the x's on one side. So that minus 4x, this, we bring this way, to the left-hand side of the equals. That minus 12, we're going to take the other way, to the right-hand side of the equals. Okay, so that minus 4x, when it comes across, becomes a plus 4x. Equals, well, we had a 2 on that side, and that minus 12 that we're taking across becomes a plus 12. So now we have 7x, 3x and 4x, we have 7x is equal to 2 plus 12, which is 14. One more little step. That x has been multiplied by the 7. Let's get rid of that 7. We're now left with x equals, it was times 7, so when that 7's on the other side, it's divided by 7, and x is equal to 2. So again, a few steps involved in that, but exactly the same method. That very first one we did, remember that was easy and we could probably just do that in our head, but the same method applies to harder problems. We just do them step by step. That's the thing about maths. Sometimes it can look really tricky, but we can often just break it down bit by bit by bit, and when you run out of bits, that's your answer. You've finished. And this video is finished.
Don't forget to subscribe and like and comment.